Hello students, we were discussing in the previous lectures the various braking methods of induction motor. So we had discussed regenerative braking and plugging. Now in this brief lecture I will explain briefly the dynamic braking. The detailed analysis of this I will not discuss in this lecture. You can go through your textbook if you want. The details are there given in the book. So I will only explain the gist of what is there because the analysis is quite complex. So there are two types of dynamic braking. One is AC dynamic braking and the other is DC dynamic braking. In AC dynamic braking, AC supply is used, and in DC dynamic braking, DC supply is used. So let us see first understand the AC dynamic braking, how it is obtained. So this is I have shown here a wound rotor induction motor, and it is normally connected to the supply. The rotor windings are short circuited and the machine is running as a motor. So what is done in this AC dynamic braking is that we create unbalanced supply from the stator side, and you know that any unbalanced supply can be resolved into positive sequence component and negative sequence component. Positive sequence component produces a rotating field in positive direction, say forward direction, and the negative sequence component will produce a magnetic field in the backward direction. So there are two magnetic fields will be produced because of unbalanced supply, and the net torque will depend on which field is dominating, which torque is dominating. So here there are two possibilities. One is known as a two-lead connection and the other is three-lead connection. In two-lead connection, what is done? Simply one terminal is disconnected from supply. So only two leads are connected to the stator winding. So it is a type of single phasing. So the supply is coming only from B and C to this motor. So this is of course an unbalanced supply, and that can be resolved into positive and negative sequence component, and it can be shown, it can be derived. You can see the derivation in the book, that if the rotor resistance is sufficiently high, then the backward rotating field will dominate and the net torque will be in the reverse direction. So you can say that the torque that will be produced will oppose the motion. In that way braking is achieved. Similarly, what is done here is in the three-lead connection, the third terminal is connected to same supply. So you can say that phase C and B both are connected to phase B, and phase C is connected to phase C, like that. So again it is unbalanced supply and can be resolved into positive and negative sequence supplies, and that will produce two rotating fields in opposite directions. And if the braking resistance is high, then the net torque will be in the opposite direction. So this is what is the gist of the AC dynamic braking. In DC dynamic braking, supply is DC, and I have shown here for two types of connections, two-lead connection and three-lead connection. Here the you can say the method is different, or the working is different. The rotor is running, and what we have done is we have removed the single phase supply, the AC supply from the stator winding, and instead we have given a DC supply. So in two-lead connection, one terminal is remained is kept open, and supply is given to two terminals. So two leads are used here. So supply is DC and the rotor is rotating. So you can say that, visualize that what is happening is that the supply is DC. It is producing a stationary magnetic field or DC magnetic field, and the rotor is rotating in this stationary field. So what will happen is that induced voltage will be there in the rotor winding, that will cause flow of current, and that will produce a torque in the opposite direction. That is the torque that opposes the cause, that is the rotation. So the torque will be generated in the opposite direction, and that will act as a braking torque, and the energy generated will be dissipated in the rotor winding resistance. Or you can say that in this case the machine is working as a generator. The mechanical energy is coming from the motion of the rotor, and that is converted to electrical energy and being dissipated in the rotor winding resistance. Same is I have shown here for delta connection also. You have to just give supply to two terminals A and B. In 3-lead connection, the things is slightly different. You have to short circuit the terminals B and C. I have not shown here. It is terminal B, and the supply is given to between terminals A and B. Likewise in the delta connection also. And it can be shown that the torque produced in 3-lead connection is higher as compared to torque produced in 2-lead connection. So this is a brief description of the dynamic braking of induction motor. So that is all for today. Thank you.